F is given by f of x is equal to x cubed minus 3x squared plus 4. So we have the function f of x is x cubed minus 3x squared plus 4. And it says find the value of x for which f of x equals 0. So it's asking us to solve this cubic equation. Now, when you're solving a cubic equation, you're going to have to use trial and error to find the first root. You can use trial and error to find all the root, but that would be very tedious, right? So generally what we do is use trial and error to find the first root, and then we're able to find the other two roots by using polynomial division. All right, so right here we're solving this equation equals 0. We need to find the first root. To find the first root, we use trial and error. All right, so let's use trial and error and solve this equation. So we're going to use trial and error. So we're using trial and error to find this now. So the first thing we're going to try is we're going to try x equal, using trial and error, we're going to try x being equal to 1 or negative 1. I'm going to start with 1. If I start with 1 cubed minus 3 times 1 plus 4, that's not 0. So let's try negative 1. If I try negative 1, I'm getting negative 1 cubed minus 3 times negative 1 squared plus 4, and that's giving me 0. So when I try negative 1, I'm getting negative 1 cubed, which is negative 1. I'm getting negative 1 cubed minus 3 times negative 1 squared, which is minus 3 times negative 1, plus 4. I'm getting that this works out to be, or this should be times 1, plus 4. I get that it's equal to 0. And so what I'm getting is that x equal negative 1 is a root. And so from factor and remainder theorem, if x equal negative 1 is a root, then x plus 1 is a factor of f of x. Now that we know that x plus 1 is a factor of f of x, we're nice. Now we can use polynomial division to find the other, we can find the other factors of f of x by doing polynomial division. So let's do our polynomial division. So we have our x cubed, we have our minus 3x squared. Now, when you're setting up polynomial divisions, the important thing I want you to note that is we don't have any x. We don't have any x in there, and so we can put a 0x and then put a plus 4. Oops. We can put a 0x and then put a plus 4. All right. So put our 0x, then we'll put our plus 4. Nice. Absolutely nice. All right, now that we put that now, and then in here, we're gonna have x plus 1. And so we're doing our polynomial division. And so we have x plus 1 into x cubed. Well, x into x cubed goes x squared. So divide, multiply, take away, bring down. Divide, multiply, take away, bring down. That's the way we do long division. All right, that was a song that was drilled in me way back when I was in primary school. So that's how we do long division. We divide and then we multiply the x squared times the x. All right, so we divide, and so that becomes x cubed. Then the x squared times the 1 is just x squared. After we multiply, then the song said take away, divide, multiply, take away, bring down. So we take away now, and so we have minus 3x squared minus x squared. that is minus 4x squared. And then we're going to bring down. What are we going to bring down? We're going to bring down our 0x. And that's the way we do long division. And then we start over the process again. So we say x into minus 4x squared. Well, that's just minus 4x. That's just minus 4x. And then we say x into minus 4x. That goes minus 4x squared. Minus 4x squared. And then minus 4x times 1. That's going to be minus 4x. And then we subtract the 2. We subtract the 2. And so we have minus 4x squared minus minus 4x. That gone. Now 0 minus minus 4x. That becomes plus 4x. That becomes plus 4x. Plus 4. And then we have x plus 1 into 4x plus 4. X into 4x. What we're going to get? X into 4x. X into 4x. That's 4. And then right here now we have 4 times x plus 1 is just 4x plus 1. So we have 4x plus 4 times 1, which is 4. And then we subtract the 2. And we subtract, and we get 0. I know it's very tedious to do polynomial division, but yep, we finally achieve it, right? Now, when we get to this now, we can factorize what's up here now, right? We can factorize this quadratic expression in the numerator, and factorizing that, to me, it appears to be x minus 2 times x minus 2 when I factorize it. And so now the question had asked us to find the roots, right? And so the roots that we found are x equal 2, x equal 2, and x equal -1. How do I know that? Because in the final phase now, when we factorize it, we can say that f of x is x plus 1. F of x is x plus 1 times x minus 2 all squared. So that's f of x. F of x is x plus 1 times x minus 2 all squared. And so the roots are x plus 1 and x. The factors are x plus 1 and x minus 2. Those are the factors. So x minus 2 all squared. X minus 2 all squared. All right. And so finally, we can conclude then that the roots, find the values of x for which f of x is 0. The roots are, we can write x equal -1 and x equal 2. Those are the roots. Very easy question, soft. Now this is question 2. Now question 2 asks us, it says, the diagram below represents a segment of the graph of the function. It says find the value of D, the value of A, the value of B and of C, and the coordinates of P. Very easy. So we're going to use the graph to answer the question. This is a cubic function. Now to find the value of D, what is going to be D? Look at the function. F of x is ax cubed plus bx squared plus cx plus d. D is the y-axis intercept. So we can write that down. D is the y-axis intercept. Right? Write that down. D is the y-axis intercept. D is y-intercept. All right. If D is the y-intercept is 6. So what's the value of D? D is equal to 6. So we can conclude D is equal to 6. Easy question. Now the next question says, what is the value of A? Now how are we going to find the value of A? All right, now let's look at it, how we're going to find the value of A. Now, to find the value of A, I'm thinking of two ways we can do it, right? I'm thinking that we can find P, find the X value at P, and then look at this. Once we find the X value at P, right? Once we find this X value at P, then we know so much, because once we find the X value at P, we'd have had the three roots, -3, P, and 2. Now look at this now. If D is 6, right? D is 6. When we multiply all of the constants, they should somehow be equal to 6, don't it? The only way we're going to get that D is 6, how are we going to get D to be 6? This must be -1, so P is -1, right? P has to be -1. So what I'm pretty much telling you is that the X value right here has to be -1, because -3 times -1 times 2, that's the only way we're going to get D to be 6. All right, just think about it. So what I'm going to write right here is that, think about this, what I'm saying. So the function is now this. F of X is actually equal to X plus 3, because X minus 3 is the root, times X plus 1 times X minus 2. All right. The function looks like this. Right? It looks like this. It looks like this is the function. Right? It looks like this is the function. It looks like. Hear the word that I use, looks like. But now look at this. If you were to expand this 3, now look what I'm saying now. This 3, we're not finished yet, you know. We cannot just say, okay, we cannot write down what A is yet. Now this 3, look what I'm saying, you know, this 3 times this 1 times this -2 is going to give us -6, right? And so the only way we can get for the final answer to be 6, or we expand out all of this, and we're going to get x cubed plus something with x squared plus something with x. We shouldn't be getting no -6, we should be getting +6. So if we multiply all of these functions by -1, we still have the same root. The only difference is that the A value is going to change. So x times x times x is x cubed times the -1, and then that is telling me that A is equal to -1. All right. Now there are other methods to do this, where we're going to talk about sums and products of roots, but we're just doing this question just using the graph, right? Just using the graph. All right. No real calculation. We're just using the graph. All right. Now it says determine the value of B and C. Now to determine the value of B and C, we're going to have to do some. Well, we don't really have to do no working out, but we can if we want to. I was trying to do minimal calculations to do this question, but here we're going to actually have to do some calculation. So now we want to find the value of B and C. Now the value of B right here is the value of B right here. Now look at this. The sum of the roots is -B over A. That's how we find sum of the roots. So what we're saying is that -3 plus -1, -3 plus -1 plus 2, that's the sum of the roots. So -3 plus -1 plus 2, that's going to be equal to -B over A. That's going to be equal to -B over A. But A is -1. So it's -B over -1. And so what we're saying then is that B is equal to, add up all of the roots, -3, -4, plus 2, that's -2. So we're getting that B is equal to -2. So that's the value for B. B is -2. All right, B is -2. Now after we find that B is -2, we need to find the value of C. Now, how are we going to find the value of c? That is too easy. Now, we're going to look at the pairwise product by 2 of the function. And so what we're saying then is that minus 3 times minus 1, minus 3 times minus 1. Okay, this is it's a little too much to write, so give me minus 3 times minus 1. So what we're saying is minus 3 times minus 1 plus the next product of the two roots we can say is minus 3 times 2 plus the next two functions we can say is 1 times 2. That's just going to be equal to, that looks like the minus, it's going to be positive c over a. So it's minus c, right? And so what we're getting now is that right here we have positive 3, then we have minus 6, positive 3 minus 6 plus 2, and that's equal to minus c. So what we're saying, which is 3 minus 6 plus 2, 3 minus 6 plus 2, that's going to be negative 1. 3 minus 6 plus 2, that's negative 1, and so c is equal to 1. C is equal to 1. So c is 1 is our answer. All right. Now, after we get that c is 1, they ask for the coordinate of p. So just tell them up here again. All right. So I'm just going to put it up here. That c is 1. B is negative 2. C is 1. B equal negative 2. C equal 1. Now, after we get that, they wanted the coordinates of P. P is just the next root. We find P long time ago. So let's just tell them what P is. So P is the coordinate negative 1 and 0. Negative 1, 0. All right, now look at this now. There's a website that you can check your answer, even with graphs. You can check your answer with anything now. But there's a website I highly recommend. So look at this. I'm saying f of x is equal to. So I'm just writing down my function. F of x is minus x cubed, because a was negative 1, plus bx squared. B was negative 2, so it's minus 2x squared, plus cx, minus 2x squared, plus cx. C is 1, so it's plus x, plus b, and d is 6. And that's my function. My function is minus x cubed minus 2x squared plus x plus 6. So what I'm going to do is check if this function is actually correct. I'm going to go to graphs and see if I'm going to get the same exact solution. All right, so I'm just checking. So now here's a website that we can check out to see if it's the same thing. So we go to Symbolab. All right, Symbolab is an excellent website. All right, and you can check your solutions by going to this. So you're going to go to graphs right here. So click on graphing. After we click on graphing, we're going to type what we had. The function that we got was f of x. F of x is equal to minus x cubed minus 2x squared plus x plus 6. Now look, let's see if we got the same thing. All right, so something looks off right here. We can clearly see something is off because look at this graph. It only has one real root, right? And so that's how we know that something is off with what we had. Right, so let's look at this now. F of x is equal to the minus of x plus 3 times x plus 1 times the x minus 1. Not x minus 1. Yeah, x minus 2. So if you look at the second one, the purple one, this looks about correct. This was the correct graph, the purple one. So something is not right in our calculations. All right, let's look at what's not right. So this is an excellent website I'm showing. So I'm just checking, right? And so I'm gonna ask it to just simplify what this is. So here it's just working it out and it simplifies this expression for us. This expression is minus x cubed minus 2x squared plus 5x. So this was our mistake. C should be plus 5. So let's check back and see where we made our mistake because we know we should have gotten plus 5. So C is supposed to be plus 5. Let's see our mistake. Minus 3 times minus 1 plus minus 3 times 2. All right, aha, here's the mistake now. Giving it away right here is not 1. 1 is not a root, it should be negative 1. So if we change this to negative 1, it makes the big difference. So scratch this. All right, so this part now, it should be, let's edit now. This part should be not 1, but negative 1. And so what we're going to get is minus 2. And so what we end up getting is 3 minus 6 minus 2. That's negative 5. And so C equals 5. All right, C equals 5. And so right here becomes plus 5x. All right, I only checked it because something fell off. And I also wanted to show you Symbolab, guys. Check out symbolab.com. It's a wonderful website. Here it is again, symbolab.com. Wonderful website for making sure that your solution is 100% correct. All right, you don't need your teacher to be checking behind you for your homework. You should be getting homework 100% in all your homeworks. All right, so that's that question. Easy, soft. Now let's go ahead and look at question 3. Question 3 gives us a cubic equation and it says the roots of the cubic equation is 2x cubed minus px squared plus qx minus r equals 0. And the roots are minus 2.5, 2, and 1. Find the real constants p, q, and r. Now to do this question, we can use factor and remainder theorem, or we can use sums and products of roots. Now let's do it both ways. Using sums and products of roots, right? This is method 1. Method 1. So method 1. Using sums and products of roots, what we're telling you is that P, using sums and products of roots, minus P over 2 minus P over 2, which works out to be P over 2, is equal to the sum of the 3 roots, which is minus 2.5 plus minus 2 plus 1. So that's the sum of the 3 roots, which is, that works out to be, let me see, minus 2.5 plus minus 2 plus 1, that's negative 3.5. So that works out to be negative 3.5. That's P over 2. Now, if P over 2 is negative 3.5, then P works out to be 2 times negative 3.5, which is negative 7. So P equal negative 7. Now the next thing we then know is that Q over 2, Q over 2, Q over 2 is equal to the pairwise product by 2, which is minus 2.5 times negative 2 plus negative 2.5 times 1 plus, that looks like plus negative 2 times 1. So that's Q over 2, and Q over 2 works out to be negative 2.5 times negative 2 plus negative 2.5 times 1 plus negative 2 times 1, and that works out to be, all right, so my calculator fidget a while ago, so minus 2.5 times 2 plus negative 2.5 times 1 plus negative 2 times 1, that works out to be a half. Now if Q over 2 is equal to a half, what that tells us then is that Q is equal to 1. Finally, minus D over A is just minus R over 2, minus R over 2, minus D over A is minus R, and so that becomes R over 2 is equal to the product of the three roots. The product of the three roots is just negative 2.5 times negative 2 times 1. So we're going to expand these now, and so we're going to get negative 2.5 times negative 2 times 1. And so what we're getting is R over 2 is 5. If R over 2 is 5, then R is equal to multiply through by 2, which is 10. So those are the values of P, Q, and R. P is negative 7, Q is 1, and R is 10. Now let's look at option 2. Option 2 is using factor and remainder theorem. Now applying factor and remainder theorem, let's do that. Method 2, factor and remainder theorem. Now applying factor and remainder theorem, what we'd have to do is they're telling us that negative 2.5 is a root, and so they're telling us a factor. So if x equal negative 2.5 is a root, then what they're telling us then is that 2x plus 5 is a fact. That looks like 2x plus 5. Let me see. Yes, 2x plus 5 is a factor. That's going to negative 5 over 2. Yeah. So 2x plus 5 is a factor. And then if x equal negative 2 is a root, then what they're telling us is that x plus 2 is a factor. And then finally, they're telling us that x equal 1 is a root. So if x equal 1 is a root, what they're telling us then is that x minus 1 is a factor. X equal 1 is a root, then x minus 1 is a factor. Now if x minus 1 is a factor, then we're pretty nice, we're straight, we're govern, as we would say, we're govern, right? How do we know that we're govern? So now the function f of x is just equal to 2x plus 5 times x plus 2 times x minus 1. That's what f of x is equal to. So now the only thing you need to do now is find out what is, when you expand all of this, what do we get? Now, because I just showed you Symbolab, now we're going to go to Symbolab. We're going to go to Symbolab. All right, we're going to go to Symbolab and let Symbolab do this for us. 2x plus 5, x plus 2, x minus 1. So we're going to go to Symbolab. So let's go to Symbolab. All right, so let's go to Symbolab. So we're going to Symbolab right here, and we have 2x plus 1 times 2x plus 1. 2x plus 1, it was 2x plus 5, sorry. 2x plus 5 times, it was x minus 1 times, I believe, 2x plus 2. Right, let's see what this simplifies to be. So what this simplifies to be is 2x cubed plus 7x squared, 2x cubed plus 7x squared plus x minus 10. Now that we're getting this for our answer, right? So we're going to say, okay, f of x was working out to be f of x what just happened? Okay. All right. So I don't know what just happened right there, but let's get back to here. So what we were getting was that f of x was equal to 2x cubed plus 7x squared plus x minus 10. Now, if we're going to compare to the original function, if you compare to up here, 2x cubed, right? So compare this original function. I'm going to copy it right here. So we'll see what's going on. Now, this is what we're getting that the function is equal to. So this is what we're getting that the function is equal to. If we're comparing the two functions, what we can see then is that minus p is equal to 7, and so indeed p equal negative 7. Q is equal to 1, and R is equal to 10. All right, so we can compare and see that these are all true. All right, that's using factor and remainder theorem. Or you could use sums and products of roots. Either is fine. Nice. Now let's look at this question.